Hello, Trent Clark with the Virginia Asphalt Association. And now we're going to cover Chapter 6, Mat Problems, in the Asphalt Field Level 1. This is the final module of this class. And we're going to talk about the things that we hope you don't see out in the field. But when you do this enough, things do happen. And you need to know what they are and what things that can be done to remedy them, to correct them. So let's go through some things. What are we trying to get in this module? What are our objectives? What are those common problems that we see in Virginia? Are those problems related to materials, the equipment? Maybe it's the construction practice. Once we know where they're from, now we can recognize them, we know the cause, now maybe we can correct them. So what are those common mat problems that you'll see throughout the paving season? Mixed segregation is by far the biggest issue that we'll see. That can be caused by many different things, and we'll talk about those causes. We see at times auger shadows, which is a function of equipment. We'll see some issues with the longitudinal joints or our transverse joints. Every now and then we might see a roller mark. Maybe it's a poor ride quality. Maybe we've gotten some rutting. And at times, do we see any flushing or bleeding of the asphalt surface? So we're going to talk about those as we go through it. So as we look at mat problems, these are defects that can occur sometimes in the asphalt mixture. It might be something that starts all the way back at the asphalt plant. But it can also happen in the field. So we need to really break them down. Is this an equipment issue? Is it something related to the paver, some use of the transfer vehicle, or is it mixed? So we need to be able to quickly deduce where that problem is coming from to get it corrected. And while there are lots of times many causes, a lot of the time some are due to the practices being used in the field to construct the pavement. Here's a nice detailed table. I'm not expecting you to read it. It's in your manual, but it lays out what are the problems and what are the potential causes. So as we go through this, you can use this as a reference to go back to and use it in the field that if I see segregation, what could be the cause of segregation? If I have this, I have checking, I have slippage, whatever it may be, I can go back to this table. Pavers can cause some of the problems. Do we have the paver set up right? Do we have the screed set up right? It doesn't sound that complicated, but at times you can see where the screeds, specifically where the crown is in the screed, is supposed to be flat across. But sometimes gremlins get in there and they move the screed around, and you can see based on the texture behind the mat or behind the paver itself, is it uniform or do we have rough areas? Maybe they're in the center, maybe they're on the outside. So you can spot maybe real quickly the problem is just with the crown, and that's something you should be able to spot pretty quickly pulling off a joint. Do I have uniform texture? A lot of these screeds now have the technology that you can check, am I paving flat? The only times you really get into putting a crown is if you're paving down the middle of a road and maybe it's a 3-lane section and you're paving that middle lane, that suicide, that center turn lane, where you put a crown there. It's not common, but it can happen. As I mentioned, by far segregation is the biggest challenge that we have. Really, it's the thing that leads to early cracking, early potholing. It can come from a poor mix design. It can come from poor handling of aggregate at the plant. It can come through the plant operations. It can go through so many different locations. So you really need to start deducing where is the crack or the segregation coming from. Here in this picture, if you look closely, there below the double yellow lines, notice how coarse that material is. So you no longer have fine and coarse material together. What's going to happen is where that coarse material is, water will get in there, air will get in there. you'll get premature cracking, and then you'll get potholing. So that's what we're trying to avoid. Now the question you have to figure out is, how come that segregation's there? Is it because of the way we're running the paver, or does it go all the way back to the plant? So we have to say, what's the cause? What's the solution? What's the impact on long-term performance? And where we have segregation, we know the pavement doesn't last as long. Here's just a close-up view. You can see what's going on there. Big rock and little rock are separated. Some of the challenges that could create it at the plant is stockpiles, whether it's at the quarry or the pit or at the plant. Is it how the plant is designed? Do we have points in the plant that cause the material to separate? Do we see the type of mix design or the type of mix? The coarser the mix, more prone to segregation because it'll have more big rock, some medium and small. Whereas if you go like to a 9.5, it's mainly all minus 3/8 inch material, less prone to segregation. It can occur, but not like we would see in a BM25. How we're loading out the trucks. Are we doing proper loadout? Are we doing 3 drops? Are we dropping it at the front, back, middle? We're doing 1 continuous dump. How we load these trucks out will impact segregation within the truck. Now we look at the pavers. So we didn't segregate it in the plant. We didn't segregate it in the truck. Did we segregate it at the paver? And again, there's many different causes that can go there. It can be unbalanced paver demand. So left side more so than the right side. So you get material falling within the hopper. Are we drawing the hopper wings too soon? So are we separating it that way? Are we not filling the hopper completely? So if the truck backs up, instead of doing a mass dump into the hopper of the MTV or the paver, we're dribbling it in. And just think about what comes first is the heavier rock and then size. So that's why we call for a mass dump. Can it just be every now and then in how we loaded the truck? You see lots of segregation on the corners. Again, segregation can happen in a lot of spots. It's trying to figure out which one is causing it and how to correct it. Good pictures of in the load. What does that mean? So when we loaded the truck at the plant, all that coarse material fell either to the front or to the back. So as you dump the material into the paver, we're not remixing it with a transfer vehicle. As that material goes through the paver and goes out behind the screed, it's very coarse. What will happen in time is those areas will be the first ones to fail. They'll crack and they'll pothole. We see temperature segregation. More so in the early parts and the late parts of the paving season, where that mix cools for various reasons. As it goes through the paver, it's not remixed. So you get this cool section coming out, and as it's cooled, it's hard to get the compaction. So again, it looks very coarse, it looks very open, and we end up again with problems. So remixing, that's why on our interstates we require an MTV. So we remix that material so we get uniform temperature flowing through. So again, temperature segregation. Segregation in the improper demand can happen in many ways. I talked about the mass loading of the hopper itself, so all the material comes out at once. We want to make sure it's a rapid discharge. The truck bed is raised, we pop the tailgate, the material goes all the way through. But even if we get it right there, we can cause segregation elsewhere. So we have to be aware of it. Dumping those hopper wings, flipping the material, separates coarse and fine. Or not moving them at all, and then you finally collapse them, and now you get a cold chunk of material. So we're not keeping, what they like to say, keeping that material alive in the hopper. We're letting it cool, or we're moving it too much. So again, this goes back to experience of that ground person controlling that hopper. Are we running the augers as continuously as possible? Are we running the paver continuously? Are we making sure that the screed extensions on the augers. So we've got the end gates out, we've got the screed out, our extensions on our augers being used to move the material. And lastly, are we doing too much handwork? Are we trying to look busy, but all we're doing is moving the mix around? Is it really compromising the overall structure? No, but all that handwork displaces the coarse and fine just on the surface. So again, it looks like segregation. So to summarize, what are the different causes of segregation? It could be all the way at the plant, it could be the paver operation, it could be too cold, it could be a temperature, it could be that broadcasting the mix, too much handwork. Solutions, the mix design. The mix design can be the issue, the plant could be the issue, getting it fixed. Loading hoppers, all those things, using an MTV to remix the material, using it properly, and just good paving practices. And if all those things are done, we avoid segregation. We avoid those long-term potholes, raveling, and the patches. And that is the biggest challenge that we face with paving here in the state, is that segregation. So let's move over now to auger shadows. What are those? If you see in this image, notice the center of the lane, how much different, darker it is than to the left or to the right. That's right where the gearbox is on that paver, which basically means we're not kicking enough material back to the center to get good compaction. And when you do density testing, you'll see right there at that dark shadow in the middle of the lane, we have lower density because we didn't have enough material there to compact. So again, causes, solutions, effects. Well, looking closer at this, what do we see? We see the shadow. What do we see in the future? A crack will form right in the middle. So if you're driving down a road and you see a nice straight crack in the middle of the lane and it's not your paving joint, 9 times out of 10 it had something to do with that auger shadow. We didn't get the density, so we did not have limited air voids. Air got in there, it cracked, just like you see in this picture. Now you can see we're having to do crack sealing. You also can see it on that curb and gutter section. Notice we didn't pave it differently, but there is a crack. So what do we do? Well, some of the causes are, it could be worn augers, it could be the kicker paddles are not properly functioning. Maybe we have some screed slope settings wrong. As soon as we see it, we need to address it. How can you see it real quickly? Just take a nuclear gauge or even a non-nuke gauge or a low nuke gauge and just go across the mat and get density readings. If it's not pretty uniform behind that screed across the width of that mat and you get to the center and you see your numbers drop, all likelihood you've got some type of issue going on there that can be addressed. Maybe it's auger repairs, maybe it's crown or slope adjustment with the screed itself. But what will happen is we will get that crack. That crack will then need to be crack sealed to keep the water out to minimize degradation. Joint problems. Water typically will get into a pavement at the joints if it's not constructed properly. So we need to make sure we have proper density, and we need to make sure that they're offset correctly and they're straight. So what are we looking at? Crooked joints? You say, well, maybe that's not an issue. The challenge that you'll see with a crooked joint is that roller operator getting enough compaction at that joint. If we don't, we have low density. Low density allows water in. Water leads to cracking, potholing. We also see joints in the wrong location. Maybe it's at the center when it should be offset. Maybe it's in the wheel path and it's not supposed to be there by spec. And we got to make sure that we're not conflicting with pavement markings. So crooked joints. What's the cause of them? What are the solutions? What's the impact? So do you have a good straight joint, or do you have something that looks just like this, where that joint isn't straight? What could have caused it? Could it be that we're not following a straight line? Could it be somebody is on that screed extending it and pulling it in? Could it be that we don't have the end gate down on that screed to confine that material, and when the roller goes across it, it squeezes it out? So what could cause these things? No end gate being on the ground. Again, that end gate, as that material is going over, confines it, gives you some initial compaction, so when you roll it, it doesn't roll out. It could very well be that we're not using that fixed reference, so we're not paving following a marking. So the paver is just going back and forth, and as it's going back and forth, so is that screed following it. We could be paving on uneven surfaces. Again, where we're getting over thickness or under thickness that causes that joint to squeeze out. So you have to understand what's going on that project. But here's 3 typical causes we see. Some solutions: get the end gate on the ground. Look at what we went through in other modules with our industry experts. Having that end gate on the ground confines the material. Having that fixed surface to follow. And if you need to, because you got an uneven surface, go for a scratch and level. Have that conversation to put a scratch and level down so we have a good uniform surface, so we have a good uniform thickness. What's the impacts? If we don't have the joint compaction properly, it deteriorates. As it deteriorates, it leads to premature either crack sealing or patching and replacement of the surface. And if it's crooked, it just looks bad. Aesthetically, it's not pleasing. What else do we see at joints? Well, low density at our joints. So what causes it? What solutions? What's long-term impact? Here's a picture of a pavement I took several years ago, and you can see a day later all the water still coming out of that longitudinal joint. That water is going to follow the path of least resistance, and when it got to the joint, it found the least resistance, and here it was coming still through the pavement a day later. Sometimes we don't have sufficient material at that joint, so as we're rolling it down, we essentially bridge it, and when we bridge over it, we don't get all the density that we need, and in time, we start getting cracking. So you start seeing cracks parallel to the longitudinal joint. And then as those cracks form, you start to get some transverse cracks. The next thing you get is you start getting potholing. So making sure that at that joint, to prevent joint failure, we have proper compaction. But again, we have in specs, and if you take level 2, you'll see that we have specs required for density at the joint. It's got to be 95% of the mat compaction to make sure that we're testing it to ensure it. And if we're not getting it, that we're doing something proactively to correct that failure, but we don't want failures. So as we look at the joints, let's summarize those things. What causes some of the problems? It could be poor rolling. We're not rolling the joint as we need to. It could be we have insufficient material, so we don't have enough material to put in place. If we're not rolling toward that joint, rolling up the slope toward a crown, we may not have sufficient material, so there's different causes there. Some solutions is proper rolling. Again, ensuring that that's being done, you're checking it, you're making sure that mat and that joint's being rolled properly. We're making sure that we have enough overlap, enough material there to overlap, and we got a proper lip. So we don't want a perfectly flat longitudinal joint. We should feel a little bit of a lip. That second pass should be a little bit higher than that first pass because we want to make sure that we're compacting it into place. Why? We're trying to avoid deterioration and premature maintenance that then ends up leading to premature having to remove and replace that surface. We got joints sometimes that are put in the wrong location. How did this happen? What is its impacts? Notice where this joint is in this picture. It's right in the middle of the lane. Why was this the case? Because the contractor was allowed to pave a 3-lane section in 2 passes. Could the equipment do it? Clearly it could. The specs call for it not to be in the wheel path. It's supposed to be over toward the edge lines, center lines. So if you could have pulled it in 2 passes, you'd have pulled a single lane and then 2 lanes. But now we have a joint in the middle that as it becomes, and if it deteriorates, where's it at? It's right near the travel surface. Another picture of another project. Again, you can see where that lane is at. Why was that allowed to happen? What are the causes? We didn't mark the pool widths right. We were allowed to pave 2 times instead of 3, or not the correct number of pools. We didn't identify where the lanes were going back. All these things should be discussed in a pre-con and prior to paving that section. Some solutions, just proper planning. It's not that hard. Making sure that you have a reference line of where those lanes are going to be demarked as you pull across the road. And what's the impacts? Again, potential deterioration. Pavement marking conflicts is an issue with longitudinal joints. Why does that matter? Well, no offset, and we have to crack seal. How does the crack sealing conflict with the markings? How does it conflict with, if we're putting in, whether it's snow plowable markers, which we moved away from, but if we're doing plastic inlaid markers, again, we don't want that joint conflict because we don't want to be cutting into a longitudinal joint that allows water to infiltrate the pavement. Because what it'll do is it'll lead to potholes. And now we have to again do premature maintenance. We're having to get out there and do crack sealing. As you can see in that one picture on the lower right, that with that crack sealing, now we've covered up our markings. So again, having those proper offsets. So when we have those conflicts, it could be we didn't mark our widths properly to say where is the edge of our pool versus where the markings have to go back. We didn't identify the lane locations. But again, with proper planning, we can overcome those things. And why? Because we're trying to conflict or stop conflicts where if we got to do future crack sealing to keep the water out, if we have to put in pavement markers, if we have to cut in rumble strips, all those things get avoided. But if we put the joint in the wrong location and we have to do crack sealing there, we cut in rumble strips, we have to put in plastic inlaid markers, water gets in there, now that leads to premature deterioration. Roller marks are still common, but they're not nearly as common as they once were. Basically, we do that when we're finishing up rolling on a mat and that roller cuts into it, and it's a mark or a gouge that we just can't get out. So it could be too cold that we're rolling that we cut it in. The mat could still be tender, and that's a function usually of the mix design and temperature relationship, or just the roller operator just not paying attention. Some solutions, pretty simple. We can monitor mix movement. Do we see it move? We can measure the temperature. We can monitor the temperature. Maybe we know there's a tender zone in that mix that we stay off of. Maybe you can roll it while it's above one range. Once we get to the middle of a range, we stay away from it. But then if we go a little bit cooler, we roll it again. So it's just monitoring. And then just doing the techniques properly. But again, why you have to do it is because we're trying to avoid any premature cracking or potholing because of the deficiency we put in the surface. Ride quality is the #1 thing that the traveling public notices. They don't really know what they're riding on, nor do they really care, but they do want it to be smooth. And of course, we want it to be safe as well. So we want to make sure that that ride quality is as good as it can be on that project. So if you don't have good ride quality, why is that and why does it matter? Sometimes you get your roller settings backwards. Instead of a high frequency, low amplitude, maybe you put it on a high amplitude, low frequency, you're beating it hard, but not very often, and you'll put ripples in the mat. As you can see in this picture, there's no way you're rolling it out. So to get rid of it, takes a milling machine. Sometimes when we're paving and we don't have a transfer vehicle and that truck backs up into the paver, you hit it, it creates a bump. Now you can't get it out. We can overcome that by using transfer vehicles. That transfer vehicle separates the dump truck from the paver. It can go through the transfer vehicle, get remixed, make it uniform temperature, go all the way through, pave it through, end up with a much better mat. Here you can see also using automatic grade control can help improve ride quality. So we have it in specs where you have to use it, but it's making sure, and in this picture you can see they've got ultrasonic sensors along a long ski pole, what does a lot of measuring and averaging and tells that paver any little adjustments it needs to make sure that you get uniform thickness and uniform ride quality, and it makes the adjustments. The ride quality does matter, but we can get problems if it's an inconsistent mix coming out there. Maybe it's hot or cold. Inconsistent delivery. You get 15 trucks and then no trucks. So you end up having to stop. Does that create a bump in the mat? Bump in the paver. We've seen that too many times, or that will lead to a problem with the mat, leads to a bump or a dip. You can't get out. Poor paver operation. Been a cause many times. Varying the paving speed. Once you start it and set it up to go, let's just say 30 feet a minute, you keep paving 30 feet a minute. You don't go 30, 45, 15 to vary it with the trucks. If you have to stop, you stop it. But when you start, you get going back at that same speed. Wrong roller settings, I showed you a picture of what happens when you have the amplitude and the frequency backwards. And then just poor roller operation. Maybe you're going up real quick with the roller, you're jamming the brakes, you're rolling up the material, creates a hump, you're not getting it out. The only way to get it out is with a milling machine. So a lot of things can lead to poor ride quality. You have to, at times, if you see it, go work your way backwards, see where is my poor ride quality coming from. But there's ways to fix it. Consistent mix delivery, consistent paver speed, use of automated grade controls, proper rolling techniques takes care of those solutions, but the impact is shorter surface life. The Virginia Transportation Research Council did a study years ago showing that smooth pavements last longer. And that study's been replicated at many places around the country and the world that proves what you intuitively know. If you pave it smooth, all things being equal, a smooth road and a rougher road, the smooth lasts longer. What does the smooth do? It also reduces greenhouse gases. It reduces the maintenance cycles. And overall, it reduces the carbon footprint of that pavement. So that's why a smooth road from the beginning is so vitally important for everyone. A few other things that's mix-related issues. Shoving and rutting. So we chose the wrong mix on a project. It could be the cause. It could be we didn't do something properly before we paved it. It could be a cause. Here's an interesting section. It's an intersection. Look at the size of those ruts. They're not very wide, but notice how deep they are. Wrong mix. That mix and that binder wasn't stiff enough to resist the channelized loads coming out of a distribution center. Mix-related issue that we could have addressed specifying the right mix. Here's another one. Notice where the truck is sitting, their tires, and notice the shear. Basically that mix is sheared. It's not spread out where you usually see a deeper rutting, but in the mix itself, it's not strong enough to withstand the heavy repeated loads, and it's just squeezed itself out. So again, some of the causes: loss of mix stability, could be a lack of binder strength. How do we solve it? Could be proper mix design. We're doing a lot of things now with balanced mix design to withstand rutting, but you also got to select the right binder. If you're going through an intersection that's got heavy channelized traffic and you call for an A binder or an A mix, you should not be surprised if it ruts. Because in that area, it's slower loads It's concentrated, it's channelized. An A-mix was not designed with that binder to perform in that situation. Now, you as the inspector, that is not a decision you make. That goes back to the person that puts together the contract itself. But that is an outcome, a mixture-related issue that wasn't a mix issue. If the wrong binder was selected, the wrong mix was selected, it goes back to the contract itself. But it's things you got to be aware of because this reduces the life of the pavement. And what will happen is if this is out on a long stretch of road and you have rutting, you can get hydroplaning, which is a safety issue, but it also leads to premature maintenance. Things neither one of us we want to deal with. Bleeding and fat spots, you see it more so in SMA, but you do see it in some dense graded mixes. But what is it? How do you fix it and what's the impact? Well, bleeding is when the binder comes to the surface. And where you see that is where you don't have proper void space or you have too much binder in the mix. And the repeated truck traffic and car traffic basically just works that mix on the ground and migrates all that binder to the surface. Here's a close-up. And you say, well, where is that an issue? Imagine if that is wet. You have a lack of micro and macro texture of the pavement, so you don't have a good interaction between the tire and the surface, and if it's wet, it reduces the friction properties. So that's why we're very cognizant of not having bleeding pavements out on the road. So when we have these bleeding and these fat spots, what could cause it in SMA? Wet mineral filler. So we're not getting good coating and distribution. Could be we don't have cellulose fibers in it. Those cellulose fibers in SMA are help to wick up that excess binder and hold it. We might have too much binder in it. We might have a poor gradation. Similar things will exist in a dense graded mix. More of those are too much binder and poor gradation that doesn't have enough void space. And again, we see those in some of the dense graded mixes. Some of the solutions, if it's SMA, it's making sure that mineral filler is dry, making sure you're monitoring that fiber feeder. Maybe you're needing to use a stiffer binder. If you're over on the dense graded side, you're re-looking at what your gradations are on your materials, how the mix is actually put together to make sure you have enough void space to accept that binder to meet those cracking, durability, and rutting requirements. But the impacts are poor skid resistance for safety, and it will pothole. So that's why we work to try to minimize and eliminate bleeding and fat spots, whether it's in an SMA or in a dense graded section. It's a lot of information. Couple things to walk away from this module are segregation is our biggest culprit of mat issues, mat problems, whether they start back at the plant or it goes through paver operations. We need to make sure that the plants are working properly and starts at load out. Rideability is a huge issue. Longitudinal joints is usually where the pavements fail first. All these things put together, if you're addressing all of those, will lead to a long-lasting asphalt surface. So good luck. Good luck on your exam. Thank you very much.